When you have a logarithmic equation where your variable is either the base or it is the inside of the log, or I like to call this the result of the log, then you can go ahead and change it from log form to exponent form and then solve it from there. So in this case, remember that you take the base, you raise it to the exponent, and it equals this value inside the log. That's why I like to call it the result. So let's go ahead and convert it. So 3 raised to the 4th power equals x. Well, now all we need to do is find out what 3 to the 4th is. So 3 times 3 times 3 times 3 is 81. And you should always check your answer. So does 3 to the 4th equal 81? Yes. Okay. So then we can go ahead and do this second example. So we convert it from log form to exponent form. So we get 2 to the 5th equals x, and 2 times 2 times 2 times 2 times 2 is 32. So 2 raised to the 5th power, is that 32? Yes. Okay. We know that that's correct. So now here we're going to go ahead and do the same thing. We're converting from log form to exponent form. So x to the 1/2, that equals 4. Now, so when you have this equation, you got to remember that x to the 1/2, that's the square root of x. So how do you undo that? Well, you square both sides. So I'll just write this so you can see. We're going to square both sides. And so 1/2 and raised to the 2nd power will undo each other, and you get x equals 16. So does 16 to the 1/2 power equal 4? That's your check. Well, that's the square root of 16. The square root of 16 is 4. So that's your check. Okay, let's do a few more of these. So go ahead and convert logarithm form to exponent form. So we take the base, x, we raise it to the exponent. Remember, x to the 1/4 equals the result 3. Now, how do you undo 1/4? Well, you raise it to the 4 over 1 power, or just 4. Right? It's reciprocal. So 1/4 to the 4th, that will undo itself. It leaves you with x. And then 3 multiplied by itself 4 times is 81. So 81 to the 1/4, that's your check right over here. 81 to the 1/4. Does that equal 3? Well, if you take the 4th root of 81, that equals 3. Because 3 times 3 times 3 times 3 is 81. Good. Okay, so now, oops, now this looks a little different. It's got a fraction in it. So let's see what happens when we convert it to exponent form. So this is x raised to the 2nd power equals 1 over 25. Well, how do we undo something that's squared? Well, we're going to square root it, or raise it to the 1/2 power. That's the same thing. Okay, so we know that the square and the 1/2, those undo each other, so it's going to leave you with x. And then what is the square root of 1 over 125? Well, the square root of 1 is 1, and the square root of 25 is 5. Okay, so that's your answer. You can check. If you replace this x with 1/5, we know 1/5 raised to the 2nd power Does that equal 1 over 25? Yes, it does. So we know that that answer is correct. Okay, so now here we have a negative value over here for our exponent. So let's go ahead again, convert it from log form to exponent form. So x to the negative third power equals 1/8. So now we're going to do the same process we've been doing. How do we get rid of the negative third exponent? Well, we raise it not just to 1/3, but to a negative 1/3 power. We have to do the same thing to the other side to keep both sides equal. Okay, so now we know that this is going to go ahead and negative 3 times a negative 1/3 is a positive 1, so that gives you an x over here. And so 1/8 to the negative 1/3, you want to take care of that negative first. So remember, it's going to basically change locations. And I'll just write it as 8 over 1, even though we can just write that as 8, to then the positive 1/3. So I dealt with the negative, and now I'm going to deal with the 1/3 power. So remember, that's the third root. So what is the third root of 8? Well, what number multiplied by itself 3 times gives me 8? Well, the answer is 2. Okay, now you can plug this in. 2 to the negative 3, does that equal 1/8? Yes, because if you deal with the negative, this is 1 over 2 to the third, and 1 over 2 to the third is 1/8. Okay, so this is the correct answer. Let's just look at a couple other examples. Again, convert from log form to exponent form. So this is x to the negative second power equals 49. So I'm going to have to undo the x to the negative 2. I undo that by raising it to a negative 1/2 power. I have to do the same thing to the other side. Okay, so negative 2 times a negative 1/2 is going to give me x to the first power. And 49 to the negative 1/2 power, you deal with the negative first, so that's going to give you 1 over 49 to the 1/2 power. And then that's going to go ahead and give me what's the square root of 49? That's what 49 to the 1/2 is, so that's going to give you x equals 1 over 7. Again, you can double check this. Replace x with 1/7 here. 1/7 to the negative second power. Does that equal 49? And so you deal with your negative first here, and that's going to give you, I should give myself a little more room here, sorry, that's going to give you 7 squared. And 7 squared we know is 49. Okay. So you can see the process is just going to repeat here. You're going to have x to the third negative 3 power equals 27. You're going to undo the negative 3 here by raising it to a negative 1/3 power. Do the same thing to the other side. You see the process here is just kind of repeating, and it just varies a little bit based on if you're getting a negative or a fraction. Okay? So here, this is going to give you x equals 1 over 27 to the 1/3 power. And so we're basically looking at what's the third root of 27. So what number multiplied by itself 3 times gives me 27, and the answer to that is 3.